This video covers the product rule. So in calculus, we have the product rule for a function where we have f of x times g of x. The product rule is going to be the f of x function multiplied by the derivative of the g of x function plus g of x multiplied by the derivative of the f of x function. So let's talk about functions that we don't need to use the product rule for. A common misconception is if we have a function like y equals 6x squared. So a lot of students do the product rule unnecessarily. For this, as long as you don't say times when you read out the function, it probably does not require the product rule. Like, we wouldn't say this is 6 times x squared, because even though it is 6 times x squared, it's really just 6x squared. So imagine if we did do the product rule, it would be, all right, so it would be 6 times the derivative of x squared, which is 2x, plus x squared times the derivative of 6, which is 0, because 6 is a constant. So we just end up with 12x plus 0. But that's the same as if we just did the general power rule where we multiply the 2 times the 6 and we get 12x. That's why we don't need to do the product rule when we have a constant. We only need to do the product rule if we have two meaningful functions of x that can't be simplified. Like if we have y equals x squared times 3x plus 1, this doesn't actually require the product rule because we can distribute x squared to the 3x and the 1, but we could do the derivative using the product rule. Now, as soon as we make this something like 7, it turns into something where we actually do need to do the product rule and the chain rule. But for right now, because we've not gotten to the chain rule, our examples are going to be things where we could multiply things out, but it's also going to illustrate the properties of the product rule. So here, I'm working examples from the textbook. It's page 126 to 129. This one is problem number 2. So for problem number 2, I always encourage you to either read the problem to yourself, read it out loud, softly if you have to. We have y equals 6x plus 5 times x cubed minus 2x. And because we have this 6x plus 5 times this is going to be the product rule. So our derivative is going to be 6x plus 5 times the derivative of x cubed minus 2x, which is 3x squared minus 2 plus x cubed minus 2x times the derivative of 6x plus 5, which is just 6. So f of x times g prime of x plus g of x times f prime of x. We should maybe, all right, this is a fine answer if we had to find the slope, but if we needed to fully simplify, we would just distribute. So we would get 18x cubed minus 12x plus 15x squared minus 10 plus 6x cubed minus 12x, which simplifies to be 24x cubed. Let's see, minus 12x is minus, well, let's put we already have minus 24x plus 15x squared minus 10. Technically, these should be reversed so that they're in descending order. Now, if we multiplied this out from the start, we would have had 6x to the 4th minus 12x squared plus 5x cubed. So we'll put the plus 5x cubed. We said minus 12x and minus 10x. Minus 12x squared, excuse me, and minus 10x. So if we take the derivative of this, the derivative of 6x to the 4th, that would be 24x cubed. The derivative of negative 12x squared is negative 24x. The derivative of 5x cubed is 15x squared. And the derivative of negative 10x is negative 10. For number 14, also, I guess this is on page 126, it doesn't make sense to multiply this all the way out So we'll do the product rule again, and we won't simplify. So we're gonna have x squared minus 2x plus 1 and multiply by the derivative of x cubed, which is 3x squared. And then we're going to have plus x cubed minus 1, and that's going to be multiplied by the derivative of x squared minus 2x plus 1. So that's going to be 2x minus 2. I would just stop here. If you wanted to simplify, it's just algebra at this point. You should be able to simplify it, but we're just gonna stop here. For number 53, we have 2x times sine x plus x squared times cosine x. So we have to do the product rule twice because we need to do it for this term and we need to do it for the second term. So we have f prime of x equals, we're gonna have 2x times the derivative of sine x, which would be cosine x, plus sine x times the derivative of 2x, which is 2. So I would encourage you to put the derivatives in parentheses so that we have some different groupings so we can see what's going on. Plus, so these two terms again come from the derivative of 2x sine x. So these two terms branch out from this. And then we have to worry about the derivative of x squared times cosine x. So that's going to be x squared times negative sine x plus cosine x times the derivative of x squared, which is 2x. So if we fully simplify this, we would get 2x cosine x plus 2 sine x minus x squared sine x plus 2x cosine x. We can group the 2x cosine x and this 2x cosine x, and we'll just cross this one out and make this a 4 instead. So the final answer is 2x sine x minus x squared sine x plus 4x cosine x. And that's sufficient. We can factor out a greatest common factor. Do we have any? No, we don't, because that term doesn't contain an x. You can maybe group these two terms together if you wanted to by taking out a sine x. So you had sine x times 2 minus x squared plus 4x cosine x. I said this, we could have sine x times 2 minus x squared plus 4x cosine x. But that's a terrible plus sign. That's not entirely necessary. As long as you get this step, if we're finding slope, that's sufficient. So the last example we're going to do is a sort of application problem where we're given that for a rectangle, the length is equal to 6t plus 5, and the width is the square root of t. So remember, in calculus, we don't like square roots, even though they give them to us all the time. We're going to make this t to the 1/2 power instead. So for 1, we're going to find the rate of change of the area, and that's going to be dA over dt. And 2, we're going to find the rate of change of the perimeter. That's going to be dP over dt. So for a rectangle, we know that area is equal to length times width. So let's talk about some notation that we haven't used before. Let's apply a derivative operator. So we're going to have, where can I write this? So d over d box. This is called a derivative operator. Whatever goes in this box is the independent variable. In this case, we have both functions written in terms of t for time. So when we put t in here, we're saying that we're taking the derivative of both of these terms with respect to time, because time is the independent variable. So the way this notation would look is we'd have d over dt of the area is equal to d over dt of length times width for part 1. So we're doing number 1. Now, when I do this in class, I like to just put a bracket here and put it around the entire equation just to save having to write this twice. So on the left side, the derivative of area with respect to time is just dA over dt. And since the length times the width, we can rewrite this as square root t, or t to the 1/2 times 6t plus 5. Again, technically this doesn't require the product rule because we can distribute t to the 1/2 here and here. But just so we can illustrate how the product rule works, we're going to have t to the 1/2, because we have to do the product rule, times the derivative of 6t, which is just 6, plus 6t plus 5 times the derivative of t to the 1/2, which is 1/2 t to the negative 1/2 power. And when we simplify this, we get 6t to the 1/2, let's see, times, or plus, we'll just put all this on the bottom. So we'll have 6t plus 5 over, so the t here to the negative 1/2 is going to move to this denominator. So we're going to have 2t to the positive 1/2 power. And if we wanted to fully simplify this, we have a common denominator of 2t to the 1/2, meaning we need to multiply this by 2t to the 1/2, which will give us 12t plus 6t plus 5, and all of this is over 2t to the 1/2. So I guess finally simplified, that's 18t plus 5 over 2t to the 1/2. That is the rate of change of the area. So if we go back and distribute this to check that work, this will give us 6t to the 3/2 plus 5t to the 1/2. And if we found the derivative, I'm just going to put an arrow and put d over dt to indicate that we have done a derivative. That's going to give us 18t to the positive 1/2 power, 18t to the 1/2 over 2, mind you, plus 5t to the, so 5/2 t to the negative 1/2. And when we move this to the bottom, we would have, so we're going to leave this, actually, we're going to have 18t to the 1/2 over 2 plus 5 over 2t to the 1/2. I'm sorry, that's out of frame. I'm sorry. So what we did from here to here was we just moved the t to the 1/2 down to the bottom. So the final step would be to multiply this by t to the 1/2. And in doing so, we get this answer. It's the same thing. So again, the product rule hasn't been necessary for anything that we've done, but that's because we haven't yet covered the chain rule as well. So for number 2, we're finding the derivative of the perimeter. Remember, for a rectangle, perimeter is P equals 2L plus 2W. So in our case, we're going to have P equals 2 times 6t plus 5 plus 2 times t to the 1/2. Now, this doesn't require the product rule, but it's just something that we're going to do because so we can keep up with like basic geometric formulas. So dp over dt is going to equal 2 times the derivative of 6t, which is 6, plus 1/2 times 2 is just 1. So we're going to put 1t to the negative 1/2. And that simplifies to be 12 plus 1 over t to the 1/2, which equals 12t to the 1/2 plus 1 over t to the 1/2. All right, so that concludes our video on the product rule. In the next video, we will cover the quotient rule. So remember, the product rule is f of x for a function f of x times g of x. The derivative is f of x times g prime of x plus g of x times f prime of x. I encourage you to, again, put derivatives in parentheses if you have a bunch of terms. It makes everything a lot easier.